So here we have some greatest common factor and lowest common multiple problems here. So when we're doing these, we kind of have to decide, are we dealing with greatest common factor or lowest common multiple? So here Tim has 36 orange flavored sweets. Peter has 44 grape flavored sweets, and they divide the sweets up into small trays with equal numbers of sweets in each tray, either orange flavored or grape flavored sweets only. Okay, so that's important that this is only. Well, if that's the case, and it says there's no remainder, find the largest number of sweets in each tray. So we have to put all just orange sweets into one tray. Okay, so for the grape ones, we can't put more than, we can't put orange and grapes mixed together. So I could do it in groups of 2. That would mean I can divide this all into groups of 2. The orange ones can be all put into groups of 2. Okay, so if let's do trays of orange, and so my orange treats, I can do groups of 2. I could do groups of 3 for orange. That would be okay, but I couldn't do that with the grape ones. So that wouldn't work. Can I do groups of 4? I can do groups of 4. Right? So I can fit 4 into this tray. And I can do 4 into the orange trays. Okay. 5 won't work, 6, and I can just keep on testing. 8, 7, 8, 9 would work for 36, but not quite for 44. 10, 11. Now, 11 would work for 44, but at this point, we're probably looking at, it doesn't look like they share another divisor. Okay, so 4 looks like to be the greatest common divisor. So what this would look like then is I would have 11 trays. So 11 trays, and I would have 4 grapes in each of those trays. Okay, so it would be grape, grape, grape. And then I would have, looks like I would have 9 trays for my orange flavored. Okay, so I'm going to try to do this quickly, but there it is. There's my 44. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I should have 9 trays. Okay, so then that would be able to put my 36 sweets into groups of 4. So each tray has a group of 4, and we don't have any mixed colors, and we don't have anything left over. Okay, so it looks like we're going to end up with what is that? That's going to be 20 trays. Okay, so the answer would be find the largest possible number, largest possible number of sweets in each tray would be 4 sweets. Okay, if we put any more, we would have leftovers based on this formula. Okay, Martin's pasting pieces of square colored paper of equal size into a board. Okay, so this board is going to measure 72 this way. Okay, and it's going to measure 90 this way. And we need to figure out how many of these squares fit into here. And what's the largest square that will fit into here, and what would it look like? So are we looking at the greatest common factor or least common multiple here? Okay, well, basically I need to see what edge length here and here, though that edge length x and x has to be divisible into 90 and 72. Really, I'm looking at the greatest common factor. So the greatest common factor of 72 and 90 looks like it's probably going to be 9, right? 9 times 8. 90 is going to be 9 times 10. Okay, well, there might be bigger ones. Actually, we should really check that, shouldn't we? Okay, so let's do this properly. Let's go. It's going to be 2 times 2 times 3 times, it's going to be 2 times 2 times 2 times 3 times 3. Those are my prime factors. 90 is going to be 2 times 3 times 3 times 5 when we factor it. Okay, so my greatest common factor looks like it's going to be 2 times 3 times 3. Oh, so my greatest common factor is 18. So that means I should be able to fit 4 in this direction. Okay, so 4 groups of 18 will fit along the horizontal, and 5 groups of 18 should fit along the, so 4 groups of 18 along the vertical, and 5 groups of 18 along the horizontal, so it would look like this. So these should be square shapes, but there it is. So the largest square is going to be an 18 by 18 square. Okay, now we could have done a 9 by 9, and that all that would mean is we can just fit, 4 of those, but we want the largest or the greatest common factor. Okay, so we want the biggest square that we could have got here.